Good noon, everybody. It's not a morning, it's an afternoon, pretty much lunchtime, so good noon. My name is Yochay Kiriaty. I'm a program manager on the Azure team, specifically work on Azure App Service. Been working with the product, the team, over 5 years now, so been exciting to see the evolutions and changes in the industries. We've been pushing platform as a service and managed platforms for over 5 years now, so it's very exciting to see that there are different traction and this serverless is picking up. Before that, I was tech evangelist, multiple startups. Obviously, none of them was super successful. I blog on App Service. My Twitter account is YochayK, and if you want to reach me, yochay@gmail.com. So I realized that it's noon, and it's just before lunch. I'm the only person before lunch. So only one person going to stand you out. So there's only 32 slides to lunch, so we have about 40 minutes, give or take, so we'll make it through. And because I know that right after me there is lunch, and probably you might not even survive the whole talk if you're too hungry, you want to get standing on the queue. So I'm going to want to walk you through something just to begin with, just to make it very light, something we call try function, which is a very simple experience of Azure Function, fully functional, but without the need to have any Azure subscription on account. Because I assume, let me ask the question, right? How many of you guys are using Azure? Any kind of Azure? Oh, okay, not bad. How many using Azure Functions with that? Only like a few. Fair enough. Now you guys are not. There are a few of the development team here with us today. Okay, so if you go to AzureFunctions.com, you click on the try free, you end up on the try Azure experience. However, slight hiccup we had this morning. So if you'll probably go to the try experience, you'll forget this mouse. Yeah, that. Go back here. So you probably want to may have the computer working. It will be good. Just hang. Okay. So you probably want to go to function.azure.com /try. Will get you to the right place. But specifically, you might want to use right now staging, because the actual site has a little bit of hiccup today. And we are in this time zone, and everybody are in Redmond, which is a different time zone. And I'm a PM. They didn't let me hold the keys to production, so I couldn't push the fix. So it's working here. And the experience is very simple. You go JavaScript, you create functions. You basically can choose which provider you want to work with. I'll go ahead and use my Microsoft account, but you can use Google, Facebook, whatever you want. You just log in, and hopefully it would work. We'll see. Takes a little bit longer than expected. Okay. So while I sign up, basically, and again, I use my Microsoft account, but you can use Gmail or Facebook. Go in. Don't have to commit for anything, no credit card, just have fun. We'll let it run for about half a second. Oh, here it is. So I created a node, I created an HTTP trigger functions. You see you can run here for about an hour. This is how much free trial we're going to give you, and you can run it every time again if you want to. But off the bat, you'll see that create HTTP triggers. You can go ahead and just run it, and you have an HTTP endpoint which you can work with. Gosh, hope it's going to get better. And my laptop is hicking up a little bit. It's the browser, it's not the. Just go away. Go. Let me try. See, that's what happened with the demo gods. All right. Seems to be not working right now. All right, we'll get to back later. So if you do go to try function, go to the staging try, should be working. As I said, we have a little bit of hiccups. This will let you allow to basically run Azure Functions with no credit card or anything like that. If you do have an Azure account, then you can use function and have it fun with it. So what are we going to do? We're going to talk a little bit about serverless just to make sure that we are on the same page. We'll do intro to Azure Functions. Again, very small, very short. Chris, later today, will talk a little bit more about it, and we have a lightning talk tomorrow, which will be hopefully much better. In terms of demos, that's what I'm saying. We'll go into more depth in the developer experience. And we're going to cover up serverless patterns and real-world example, which will be the majority of this talk. So what is serverless in a real quick nutshell? The first thing we do is basically abstract the underlying servers, right? So it's a fully managed platform. We take care of everything for you. So you don't see the OS, you don't see the VMs, we patch for you, we have the framework for you. Basically, you guys get your code, deploy, and it runs. So this is the first layer of abstraction. Then it's event-driven, right? There are event HTTP triggers, there are queue triggers, storage, multiple event sources that you can work with. And when there are events, we basically run your code. When you get more event, we run more of your code. Then you got a lot of event, we run a lot of your code. That's all the part of the instance scale. So you get really scale, very fast, and event-driven. And all this, basically, you only pay for when you run. So if you don't have any events, you're not running, your code is not running, you're not paying for anything. So you're not reserving VMs, you need to pay in front for anything like that. I think you guys are pretty much familiar with that, just in case you're not. So what does it do for us? How does it let us do it? And you're going to see a lot of people talk about the benefits and how does it come into fruition. So basically, it reduces DevOps. There's a lot of conversation whether it reduces DevOps, it changes DevOps, there's no DevOps, a lot of around that. But basically, it lets you focus on the code, lets you focus on the business value without all the other boilerplate around it. We don't need to manage VMs, worry about them, monitoring them, and all that. It lets you focus specifically on the business logic. So your developers or you can basically just write code directly when you need to do it. So you have a function, you have a task to implement, you actually go ahead, write that code, just one small encapsulated, and then you move forward. All of that basically reduces the time to market, allow you to really quickly iterate and step in and basically work and produce value really quick. So you can do real quick MVAs, get an endpoint running in seconds, and then deploy it and everything works. Okay, so I don't know if Sam is here. This is from Sam. Yeah, Sam, I don't know if Sam, I don't think Sam is here, but this is basically at the high level a cloud guru architect in terms of their serverless application. So you'll see a thick layer of Angular JS client, basically smart enough client to work with Auth0 for authentication. They use API gateway from AWS that fronts a bunch of Lambda functions to actually run. Firebase is the database, Stripe for payment, completely serverless end-to-end application. However, this is going into that, building that, the whole thing. First, you need to know a little bit what you're doing. Plus, you can do it really quick. It's a big thing. However, you need to build a whole app for that. And what we see is there's a lot of other opportunities for everybody just to start venturing into the serverless, trying to nitpick exactly what you want to do, find a little thing that you can actually start working with serverless that are not necessarily the full Monty end-to-end full application. So whether you have a small cron job that you want to run on a period basis, it's perfect for a serverless. If you have some triggers or some files are being uploaded to your storage, you want to take action upon that and so forth. So there are a lot of options, and where do you want to start is just pick your option where do you want to start, and you can start exploring a little bit of the serverless world. So with that in mind, what does Microsoft has to offer around serverless in terms of services? So obviously we got Azure Functions. That's the serverless compute offering that Azure has in terms of Azure Functions. We'll see a demo. If the trial not going to work, we're going to go switch to the full production. Other than that, we have logic apps. Logic apps are basically managed workflow. And if you think about logic apps in an instance are also serverless compute. They react to events. They can scale like crazy. And they basically allow you to express a little bit of conditions and actually write a little bit of code with that. And they are perfectly extendable with functions. But there are many, many other serverless features within the Azure portfolio, and there's a lot more. I didn't just put everything here. But whether you want to do machine learning or cognitive services, everything with networking, storage, NoSQL, obviously, a lot of things with IoT Hub, Event Hubs, many, many different services, including Visual Studio, if you want to do manage your DevOps, all of that completely serverless. You don't manage any of that. It's a fully managed service. You just use it. All right. So with that in mind, I want to touch a little bit of the programming model around function. Again, just a short intro just to make sure that we are on the same page, because there are some aspects of Azure Functions, namely binding, that I want to show you how they work. And for that, let's just go really quick and see if this thing is as I want to behave nicely now. Let's see. Give it one more try before we go away. Let's go a little bit better. Okay, so I'm not sure what happened before, but again, so this is all the try portal. You can still work. I have 52 minutes, which should be enough for our conversation. So as you see, I created an HTTP trigger function, and off the bat, you guys see nothing on the back. Sorry, let me zoom in a little bit. Better? Okay, a little bit better. Off the bat, you have an endpoint, HTTP endpoint I can interact with. So it expects basically a query parameter. I can show you to here. Actually, you require either a query parameter pass as a get or a post. So let's just add that as far as what we're doing. Azure, let's do your encoding. All right, hello, Azure Function works. Yay! So that works, fair enough, easy. What I want to do though, I want to actually to show you the binding is how we work with other input-output. So we go to the integrate tab. You can see here we got the triggers that comes in. This is a HTTP trigger. We have other triggers. We can see them in a second. What I want to do is basically go ahead and add an output binding. Say I want to write some sort of the message. And you can see we have a lot of output bindings. The reason those are grayed is because, again, it's the try experience. It's for free. There's nothing there. But if you go to the full, you have a regular Azure subscription, then actually you can go ahead and have fun with it, and you have access to all of that. But you can see we can definitely write. We're going to use storage queue for this example. But there's other example here like SAS files, so we can work with Dropbox, for example, or OneDrive. There is SAS tables, for example. You can actually write and work with Salesforce in those conditions. We can send email with SendGrid. You can send SMS and do other stuff with telephony, with Twilio. And you can do it directly through the functions without actually bringing and carrying, without actually carrying or understanding how does the SDK for those are kind of working. What does it mean? Let's use storage just for simplicity. Hit the select. Output queue, I need to copy this just to remember. I'll hit the save. So we added that, okay, we good. So let's go back for the code for real quick. And what I want to do is basically I'm gonna add a single line, and again, for interest of time, I'm just gonna copy that line, make it simpler. So basically I'm gonna go to my context, I'm gonna have an object on it called binding, and the binding represents all the bindings we can have, either input or output for the functions. And output queue item is one we talked about, and here I am just creating a very simple JSON object, and I'm adding the query name that comes in. I'm going to hit the save. I have some cool option in terms of the experience over here. I can hit run. Run will allow you to set some parameters. There are new stuff that we added to HTTP triggers like routes, and you can choose the method, but basically let's just hit the run button. Or let's hit the logs. Let's show the logs as well. I'll hit the run button, and you can see that actually it ran, returns hello Azure. This is great. This is the object we are passing in the body, and I can run this again, obviously. Let's add another question mark, hit it, and voila. Cool. So this was cool. This is working. That's nice. I want to go back to the integrate storage account, storage queue. So what we have here is a little bit of a helper. Hey, you're putting something on a storage, maybe you want to queue out of that. So when there's a new item in the storage, you want to queue. So I said, yeah, let's do that. And basically, I'm just going to hit the create for all the defaults. We'll go ahead and create a queue object, a queue trigger function for me. And if I look at the log, you're already seeing that, hey, it's actually ran and already collected some of the logs. So here's hello Azure, here's hello rocks, and I can go here and we'll add a few more exclamation mark got it back, and we should be able to see more of them showing up here. So this was a really quick tour of Azure Functions. And the idea here is, behind the scene, what we're doing is we are building a programming model that makes developer a little bit easier in terms of what the tasks they're doing. So we created an abstraction for all the serverless, right? You don't need to do anything with compute. But on top of that, we had a little bit more. So you get requests, which comes with triggers, and usually carries data with it. It's just not a point in saying, hey, you have a new item in S3 bucket, you need to go get it. We're actually going to give you a handle, either the object itself or a handle to the object, depends. On the context, you saw there is binding, there is request, there is response, obviously, that you can do. And as you can see, I can write to the binding. And over here, we have binding, and the whole bindings are being basically declaratively defined. So if I go to my integrate tab, and the advanced, you'll be able to see this one. You're able to see basically all the binding that we are using. HTTP is an input, and response value is in the queue on that, and there's the connection string here with the representation. So this now can be automated and put into your DevOps production, right? So you'll be able to basically separate code from connection string. You'll be able to articulate this into your DevOps pipeline. All right, so about half the time, actually not half, 15 minutes in, only one more slide to lunch. Hope you guys are still with me. Let's talk about real-world examples. So Chris will go into a little bit more of the depth of the actual Azure function. I want to talk about what customers are actually doing and using Azure Functions for. So let's start with a simple scenario. We'll go with scenarios, articulation, and then we'll actually go to the customer example. So let's say somehow magical way, you get a file on a blob. You basically want to, we get trigger of that, so your function will run, read the blob, do some data manipulation, stick it into a table or anything like that, and then you can have some Power, in this case, Power BI for representation on top of that. So what do we got? We got a friend, Troy Hunt. He has a site. He's a security person. He has a site, and he is constantly being bombarded by his fellow security guys trying to DDoS him and hack. So basically, he has a lot of DDoS attack, and he wants to protect against that. So he put Cloudflare in front, but basically, Cloudflare will allow you to block specific IPs, and he needs to dynamically configure those IPs. So what does he do? So he has a site, and there's a DDoS attack. He recognizes this. He puts in a queue message, basically which IP he wants to block. There is a function that gets triggers off the queue, similar to what I've just shown you, and then he uses the API to communicate to Cloudflare to basically block it. And then over time, IPs changes and so forth, so he has a periodic timer, basically a timer-based function that will run every now and then and just clear the list of IPs, and so on and so on. The next thing about it is what I want to show you is like, hey, so he did the work, this is good, it works for Troy now. Before serverless, if you would want to achieve that, what you would have to do? You'll have to set up something, a VM, a container, a web job, which is a concept of Azure App Service. You need to create that, you need to run that, you need to deploy. You need to, if you're running a VM or container, you actually need to build, deploy, manage, patch the OS. You need to monitor the infrastructure. This is the entire part of the server, and this is, again, before serverless. And this is even before writing a line of code that you really care for in terms of actually fulfilling the task that you are going to do. To do that, Troy needs to use the Azure SDK because he needs to read from a queue. He needs to basically use Cloudflare credentials. He needs to manage them. He needs to somehow write them somewhere and work with them. And then he needs to use those credentials to work with Cloudflare API or the SDK to actually do whatever he was going to do. So he needs to do all of that work just to be able to make a single API call. Using serverless, basically, hey, we eliminate a lot of the stuff that you can do, or you need to do, basically, and now he needs to just manage Cloudflare credentials, and he can do it with dynamic settings. Within App Service, there is a concept in which you have your settings, your application settings are separated from your code. So please don't check out secrets. Don't check into your repo secrets, right? Separate them. With App Service, we have a way, basically, to automate the entire process, so you can obviously control the configuration separately from your code. And then, obviously, you need to use the Cloudflare API. The one thing that we do look into this and learn in terms of best practices, and we'll have a few of them through the slides, is that, hey, the functions were very, very simple, and that was on purpose. Your function should ideally do one thing and one thing only. There is a single task, there is a function, it's small encapsulated, just like you write code, you would expect to have input parameters and values there, and you want your function to do a single item or a single task and move on. So it's important, and we'll see why a little bit later. Next, periodic Timebase, probably the most calling scenarios to actually use serverless, because if you have any kind of timer-based cron job activities today, you have a server basically that runs there and spins for nothing. Only when the cron job kicks in, you need to run. So we have a timer base. In this example, you clean up some data, you look at the table, you clean it up. You can basically every hour send emails, or you can do whatever you want, and you get up a clean table, or you send emails, or again. So in our example, we have a company called AccuWeather. AccuWeather provide weather forecasting very accurately, I guess, or superior accuracy. And they wanted to replicate blogs from one data center to another. And if they're already doing a replication, they want to analyze the log and take any action on some abnormality that happened to the log. Doesn't matter what form of the log are. So again, what they do, they have FTP. They have a function that actually downloads those FTP files, put it into blob. There is a second function that actually being triggered from items on the blog when they appear. Those are taking those log files, parsing them, putting them into cold storage, which basically it's a table store. So you take a blob and you put it into tables, something more structured. And on that, you can actually run stream analytics, and anything over behavior that's being detected, then you can take action upon that. Cool. So we'll go through the same exercise. Hey, so AccuWeather actually managed to finish their task. Before serverless, the same whole deal, right? If the whole thing of the server, we're not going to go through that again. And very similar to the previous example, they need to manage FTP credentials, they need to use FTP libraries, and they need to use the Azure SDK to actually be able to read items from QBlob and work it out. And just like before, you don't need to use servers, so you don't care for that. The FTP is being managed with dynamic settings, and they use FTP library. So pretty much the same thing. That's not the reason I put this slide here. The reason is that I want to talk about actually some optimization here. So this is the structure. And anybody has an idea why this is a bit risky with serverless, and where would there be a failing point or possible failing point? Anybody? Anybody want lunch? No? So the thing is that the FTP download function, what happens if the connection is very slow? What happens if you have a lot of files to download? This could take a long time. Basically, we limit our execution time for 5 minutes, but even if you wouldn't limit your time, by definition, having something running that long is not ideal for a lot of reasons. So what you can do for optimization is basically take, hey, this FTP download now will actually shard the work on whatever algorithm that you want. It doesn't really matter. A single folder, a single file, a size of a file, or multiple files, it doesn't really matter. As long as you shard your work, you put it in a queue in those examples, and then from each queue message, basically, you'll have a different function that will trigger out of the queue message, and that will actually do the copying to the blob and so forth. And you probably can do the same thing for the blob replication job if you want to. The reason this is important is because now we took away, now we had the ability to actually scale. Because if you have a single function that needs to copy the entire FTP content, now you have a lot of functions copying small parts. And we are taking care of that scale, so we can run at parallel. So we basically parallelize the tasks. So this is where we go into a little bit of the architecture around serverless. We need to buy into that concept to be able to take advantage of the platform that gives you that. So you shard your work, you put it in a queue, and now those items run on their own, which is good because you basically can finish the whole work a lot faster. So what we learn from this is that you want your functions to run as quickly as possible. And it's important because let's say you have a function that runs for whatever, 30 minutes, and it fails on the 27th minute. Now you need to run another again. So collectively you ran for 57 minutes. Where if you were running, let's say on sharded of 5 or 3 minutes, only that segment that failed will need to be able to run again, and you'll be able to run in parallel. So this is why we actually want our functions to finish as quick as we can. Make sense? Cool? Okay, hey, we're almost there. Only 10 slides. 10 more slides. So, another example. Another example is real stream processing. Anything that generates a lot of events, a lot of messages coming through, could be IoT, IoT related, could be other things we're going to see. Basically go through stream analytics or go through functions, and be able to basically perform some sort of transformation on the objects, on the data, and then just push it down the pipe for for our additional iterations. This time we push it into SQL, and other workflow can actually kick out of that. Okay, so we had a Power BI. Power BI is a Microsoft team, but it's basically a different team from us. So we work with them. As far as are concerned, they are the customers. They wanted to basically create an experience that allow you to manage, basically see the results of this, like a social campaign, like how does a social activity goes around something that happened that we did. So they want to collect tweets. They want to analyze tweets, and they want to display rich analysis on top of that. So how do they do that? So they need to collect tweets, so there are certain tweets. We use logic apps to do that. I'll show it to you in a second. Use logic apps to collect tweets. Those are being analyzed and parsed by a function, which then push it into a database, and then we use Power BI basically to display the data. So with that, what I want to show really quick is just show it to you. It'll be easier. And let me just show you the end result initially, and then we can go through how we did it. So the end result looks like this. This is me collecting basically the hashtag serverless. I'll show it to you in a second. You can see right here in the middle, there's a lot of serverless noise around this, and this is just a view of all the different hashtags and different authors that are assigning. You can see here the different load, the spike. So there's a lot of serverless news on October 12th. Any idea why? Some of you listening to know what happened on October 12th for serverless. No? Serverless framework went GA v1. That generated quite big of spike. You can see here up at the top, our friends from IBM, OpenWhisk, they had open. Basically, they did some training yesterday, so you can see those effects over here. If you're good enough and lucky, you'll be able to find. Obviously, you'll find Lambda and AWS over here. Cloud Guru, Serverlessconf should be here somewhere around here as well. Microservices and so forth. You could look at pivoting information, the tweets themselves, how many came in, the different hashtag, all the authors around that, negative, neutral, positive, everything around this. I have no idea how to use this other than just show the fancy graphics. I'm not a marketing person, but you get the idea behind what is running here. So just to show you how it works, yeah, great. Let me relog into Azure Portal. And basically, this is how it works. So Logic App is a managed workflow, and as soon as this loads, I'll be able to show you the managed workflow. See, this is what happens when you do live demos with Wi-Fi internet. You take risks. Let's see if the risks pay off. Come on, you can do it. You can do it. So this is extremely simple workflow, but you can see there a little bit more. So I got a tweet come in, and everything there is serverless, I'm going to basically collect it, and then I'm going to push it down into a function to do whatever needs to happen. I can add additional steps here, and there's a lot of stuff you can do. You add conditions, you can build complex examples, and as you can see, there's a lot of connectors that we can connect to and work with, and the list is very, very long. You can load more and more and more, and I'm not going to tire you through all of this we got. You can also use specific APIs. So if you have your own API, you build Swagger, this automatically will be light up. So as long as you have your Swagger definition, everything works. API management, the ability of Microsoft tool basically to manage API professionally. Any other logic app, so you can compartmentalize the logic. As we said, logic app are also serverless compute. You can think about it. And obviously any Azure Functions. So with that in mind, let's just see how the Azure function is for this particular one. So this Azure Functions, that actually there is a log analyzing the log. Analyzing the tweets is loading shortly. Is actually ignore the hiccups. Is actually written in Python, so we support Python as well. It's an experimental code that we have, but it's there. And I don't read Python, so I have no idea what's actually is in here. But they choose to implement their own analysis, to actually run some own algorithm on the tweets over here to do the sentiment analysis. They could have used cognitive services and just make an HTTP call with the body and do all the other works. But they decided to do it like that, so it's up to them. Definitely entitled to do that. Okay, so we're back to the slide. So we've seen the demo, we've seen how it works. Same exercise here, we'll just go a little bit faster now. You need to do all the VM, and then you do a bunch of other stuff. Hey, you need to connect to Twitter, so you need to do the auth around that. You need to work with SDK. You need to analyze the tweet. You need to build rich client to show the result, right? If I would told you, hey, you guys need to build this 2 years ago, you'll need to do something along those lines. A lot of work. Today with serverless, you don't need to do a lot of work. You basically just need to analyze the tweets. And even with that, if you use cognitive services, if you have cognitive services, basically, you can make a different call to any machine learning or cognitive services from Cortana Analytics to actually analyze the tweets for you, if you would like. And you can build a bunch of other reach. So this is the power of serverless that comes into play. Small thing that you can use, this is actually big, to boost your performance or boost your time to market or whatever you want to call it, because you can get this done really, really quick, really, really effectively. All right, so we have only 5 minutes, so let's go quick. Function should be stateless and should be idempotent. This is all ideally. State is bad. State doesn't allow you to scale properly. There are ways to work around it. Just don't use state in your function. There are ways, if you're really interested, let's have a chat a little bit later. And idempotency is important because you can, if your function explodes or anything like that and you're analyzing a tweet, you want to be able to analyze it again and so forth. I haven't showed you that, but the logic app actually has a history of the runs. If something failed, you can rerun this. So you can build DevOps around that. You can put it in a poison queue. You can do all the messengers around it. So all of this works great. Plexure is a company. It's a marketing company. And basically, there's a geofencing marketing. So you go into a store, you use your devices. They get information from sensors, from point of sale, for all bunch of places, and they'll basically, based on your location and a bunch of history and how much they know, they basically will target you with advertisement, in a nutshell. And what they were looking to do is actually, let's go through the slide. So they have a lot of input. Input can come from a lot of sources. Obviously, web, mobile, but point of sale, kiosk, bots, sensors. A lot of things goes through a very big ingestion pipe, event hub, that then is being analyzed on Stream Analytics, and you can see they're using both workflow to orchestrate some of the logic that they want, and they extend the workflow with function to actually run custom logic, similar to the pattern that we've seen with the tweets. So with that in mind, let me really quickly show you how does it look in practice. So I have an account on Plexure, Plexure.io, really cool stuff that they're building. Hopefully it's still logged in. Yeah. Okay. So what they have here is a very simple workflow, which I'll show it to you. It's really simple. It's a manual triggers. You can obviously think of there are other triggers. But what they're doing here is they're looking at dwelling history and shopping cart. So imagine you go into in the supermarket, you want to buy some stuff, you take a shopping cart. Well, not all, but some of the shopping carts today have sensor on them. So they can track you through the store. And then when you come to register, to pay, if you use your membership card, which most of us do, they can correlate at that point. Fair? So they do that, by the way, if you didn't know. And then they can say, hey, you bought this great fish, but you didn't pair the wine that goes with it. So even if you finish already your purchasing and you get out of the register, they'll send you a message saying, hey, do you want this at a discount and whatever. Fair? So this is the scenario that goes. The thing that they built, so this behind the scene translates into workflow, but what the cool thing is working for them, they can take the actions, you can see the different actions like dwell history and so forth, and those are mapped into functions. So those are Azure functions, basically, custom Azure functions that their customers can use. You can look here. Basically, they'll give you the information, then the schema that goes in and out. So this is cool. The really cool thing is that people using Plexure, if they are advanced, they can actually go ahead and add their own customization on top of that. So they can go into this dwelling, and this is basically an Azure function. They have wrapped the experience in their own. So they let you write custom code. You can run with against your whatever you need to run if you want to extend their basic API and provide your own custom logic, merging multiple inputs into a more cohesive story for them. So this is how they allow their customer to take advantage. And this is cool because the customer doesn't know it is running functions, but for Plexure, they resolve a lot of problems. They don't need to care about security. This thing just runs and so forth. So it goes for them. And I'm almost out of time, or right, I have a few minutes. So let's just go through to the summary slides. Okay, so basically, if you look at everything we showed, best practice really quick is in summary. Your function, if you have them, make sure they do one thing, ideally. Should finish as quickly as possible, which allows you to basically to scale a lot and more resilience to think about it. Stateless as well, if you talk about scale, is important to basically not having state within your function, basically because function can run on separate infrastructure as well, so it's another reason not to keep scale. And idempotency is good, but if you can't have it, then it's not the end of the world. And when you think serverless app with other functions, so instead of polling and stuff you need to do, you can use triggers, because triggers come with data, you can work with that. Instead of SDKs, think of bindings. Our binding story, as of today, is good, and it's extendable. We're working on the ability to actually open up. Everything is open. Everything we do in Azure Functions is open source. Chris will cover that. But the binding basically will be extendable. So you can bring your own binding. If you want to write to a different service and you want to provide it as an option on the Azure experience, as you can see, at some point in the future, near future, right, Matt? Near future, we'll be able to open it up and allow other people to bring their own binding. When you instead of building and deploying servers, hey, you're working with functions now. It's a lot easier to do that. Anything about scale, do async. And the last thing I want to talk about is live and die on the cloud, develop on the cloud, test on the cloud, ship on the cloud. As you see, we are experienced in building Azure Function. You can do it in an editor on the cloud. We'll show later today and a little bit tomorrow a bit more of the exciting stuff we can do actually on the local dev box as well. But definitely want to use the services on the cloud, do your development on the cloud, and have fun on the cloud. So with that in mind, this is pretty much the last slide. You can go to try function, you can go to try app service, and we have a little bit of challenge. We brought a few extra hoodies with us. So if you guys go to try, to basically aka MS try functions, remember, do the staging. I'll put the slide in a second. If you go up and show us some cool function that you've built, something interesting and nice, we have about 8 or 10 of those spares hoodies that we'll be able to basically give to you. So we are going to be at the booth, Microsoft booth, and if you show us something you create on try functions today or tomorrow, and if we have more of those, or if we have left, then you'll be able to get your own. It's pretty cool, right? It's a cool hoodie, right? Cool hoodie? Cool hoodie? Yeah, I think so, yeah. Okay, so with that, I would open the floor for Q&A, but I think you're going to say to you guys, enjoy lunch. Thank you very much.